right? And you want 2 Republicans. We have 2 different problems. You have 60 Democrats, you're going to pick 3 of those randomly. You don't care what order. And then from the 40 Republicans, you're going to pick 2 of them. And then you're going to have this combination that could mix with this combination. It'll be 3 of those with 2 of those. So now you have 3 of those, 2 of those, 3 of those, 2 of those. So now you're going to multiply all those combinations. Okay? To save time, if you do the math, 60C3, you get, and you could just type it in your calculator if you don't believe me, you get 34,220. So 60, math, PRV, C3. See? Got that? Yeah. And then for here, you'd have 40 C2, 780. By the way, I don't know if you noticed what I did there, but I didn't feel like typing that again. A trick, if you go second enter, it'll pull it up. So second enter, and then you can just change the numbers. Like if you wanted to change it back to 60C3, I think that's easier than typing it in again. See? And then maybe I want to do 40C2. Saves time. So then with those 2 numbers, we have these 3-person committees, we want a 5-person. So we're actually going to multiply those 2 numbers together. Oh, sorry, my brain is off today. Times 780 is a lot. 26,691,100 committees. Does that make sense? Now, if for some reason you didn't care if they were Democrat or Republican, then your problem would change to 100C5. Does that make sense? So if you didn't care if they were Democrat or Republican, you just wanted 5 random people, then your problem would be 100C5 and that's it. But you do care the different number, okay? A zoo has 6 male bears and 7 female bears. That's a lot of bears. I don't think I've ever seen that many bears at a zoo. 2 male bears and 3 female bears are chosen for a show. How many 5 bear collections are possible? This is the exact same problem, correct? We're talking about either you're a boy bear or you're a female bear. I believe many bears have spoken up about not either or being both, correct? So you have 6 male bears. We'll make 2 columns. We'll make our males. We'll make our females. So we have 6 males. And we have 7 females. And then of those 6 boys, you're going to pick 2 of them. Those 7 females, you're going to pick 3 of them. And notice this number plus this number, these two numbers add to 5 because you want 5 bears. You have a total of, what, 13 bears? Right? So you do the math, 6C2. If you have 6 boys, delete, 6 boys, and you pick 2 of them, that's only 15 combinations. Right? And if you have 7 females and you're picking 3 of them, that's 35 combinations. So after you take your bears, your male bears, and like bear 1, bear 2, bear 3. I'm sorry, there's only 2. Bear 1, bear 2, bear 2, bear 3, bear 3, bear 4. Bear 6, bear 1, bear 4, bear 1, bear 6, bear 3 and 4, bear 3 and 5, bear 3 and 6, bear 5 and 6. If you list all those out, there's only 15 combinations. There's only 6 males and you're picking 2 of them. There's only 15 combinations for boys. But then when you have 7 females picking 3, that opens it up more, and you have 35 combinations. And then you're like bear 1, bear 2, male, with bear 1, bear 2, female. And so then you have to mix these together. So you multiply 15 times 35, and you get 525 combinations. Does that make sense? I just kind of feel like just 1 second. Okay, so if we have male bears, 6 of them, I think this will help. So you have 6 boy bears. We'll call them male 1, male 2, male 4, male 5, male 6. Right? And then you have 7 females. So here you're picking 2. So you might do M1, M2, M1, M3, M1, M4, M1, M5, right? M1, M6. Do you understand what this means? Male bear number 1, male bear number 6. And then you go to, and in a permutation, you would then list M1, right? But these are the same thing. So we cross that off. Male 1, male 2, male 2, male 1 are the same thing. That's why you end up decreasing the options. But then we would have male 2, male 3, male 2, male 4, male 2, male 5, male 2, and male 6, right? And then we go to our male 3. We're not going to mix it with male 1. We already got that combination, right? Male 3 and male 2. We already got that somewhere. So it'll be male 3 with male 4, male 3 with M5, and male 3 with M6. And then 4 has already been paired with 1, 2, and 3 down here. So then we go male 4, male 5. And then male 4, male 6. Male 5 already been paired with 1, 2, 3, 4. So we would just do male 5, male 6. And if you count those, 1, 2, 3, 4, 5, cross that one off. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's how they get 15 combinations. If order mattered, then we would not be crossing off all the ones that were duplicates, right? That's why there's fewer. And then when you have how many females picked? 3? And I'm not going to list out all 35. I have better things to do with my life. But F1, F2, F3, right? Or maybe it's F1, F2, F4. Or maybe it's F1, F2, F5. Or maybe it's F1, female 2, female 6. Or maybe it's female 1, female 2, female 7. Dot, 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 dot. I don't feel like listing them all out. But then you could have this with this, or this, or this with this, or this with this, or this with this. You could have this with this, this. See how that's going to work? Now we're going to use the fundamental counting principle that says you take number of these, like your shirts, number of these, your pants, and just multiply them together. Does that make sense? That's why we multiply. Because all of those are going to go to each other. All right. So you should know the difference between a combination and a permutation. And you should know how to use combinations. Our objective today. 1, 2, 3, 4, 5. Okay. I'm going to break this up into 2. 1, can you distinguish between combinations and permutations? Can you read a word problem and then decide yourself, is that a permutation or is that a combination? Do you know the difference? Do you know that those are two different things? How do you feel about that? Kind of like saying, pointing at someone and saying, is that a boy or a girl? Really the same thing. It's either one or the other. I really need to change that example because it isn't always true. And then you solve combination problems. Decided to make these two different standards. Really are two different skills. Can you tell the difference and can you solve combination problems? Those are always permutations. Make a question. Okay? There might be some permutations in your homework. Now, probabilities using combination. Stick with 90. I'll give you some practice on Excel. But what we do tomorrow. Today is November 15th. So I'll have it due tomorrow. Worksheet is labeled combinations. Now, one thing I find interesting while I'm thinking about it, which is usually what I open up with, what is that called? Huh? What's it called? If you were going to the store and wanted to buy one, it's called a combination lock. How do you open up this lock? Yeah, so you have 3 numbers you have to put in. You go to the right first, then you twirl to the right. There's more that goes into it than that, but you have to put in those 3 numbers you give you first. It does. First, it will not open. The name of this is order does matter. Permutation lock. That's the proper name. Permutation lock, because the order that you put those numbers in does matter. So it is not a combination lock. Does that make sense? All right, that's all.